and welcome back to me, I guess. I have been away from YouTube for a very long time, and I'm here to talk after a much too long of a pause about angles and angle relationships in particular. So rather than going through the things that we've been doing in our lessons problem by problem, I decided to put up one big problem where I can illustrate the four major angle relationships that we've been talking about and kind of talk about how those all can interact in one big problem. So what you see here, an angle puzzle. I have no angles specifically labeled. There are no degrees listed anywhere here. But using supplementary, complementary vertical angles and triangles, I'm going to be able to figure out every angle measure that is in here. Oh, I lied. I need one angle. My bad. I am going to choose an angle measurement for this one. And notice that for this problem, I'm not using a protractor. Sometimes problems can be drawn not to scale, so do not always trust when you see something written on paper that you could just use a protractor to measure it. So I'm going to say that this angle right here, we'll call it a 63-degree angle. Does it actually look like a 60-degree angle? Doesn't need to, because I'm saying it's a 63-degree angle for the purposes of this problem. So, looking at this, I now will posit that I can find every other angle that is in here. Okay. So, first I can think about supplementary angles. This is where we talked about having some kind of line, and a line is 180 degrees. It's half of a circle. And it's broken up in some way. So it could be broken up like this, into just two angles. And I could say this angle plus this angle, angle 1 plus angle 2, measure of angle 1 plus measure of angle 2 equals 180 degrees. But I don't have to stop at 2. It could be split up in other ways as well. It could be split up into 3, where I have measure of angle 1 plus measure of angle 2 plus measure of angle 3 all together are going to equal 180 degrees. I want to see if I can use this to find any angle relationships here that are supplementary that I could use to start solving. So I want to look for lines that are being intersected by other lines or other line segments. I notice I've got a line here. And to make this easy for relating these angles to each other, we could call this angle 1, and we could call this angle 2. Let's just keep going. Let's call this angle 3, angle 4, angle 5, angle 6, and angle 7 is this one. So, looking at this, I saw a straight line. I know that this is going to then measure 180 degrees. Given that, I can say that measure of angle 1 and the measure, or angle 1 and angle 2 are supplementary. Because when I put those two angles together, I form a straight line. So I can say angle 1 and angle 2 are supplementary angles. That means that the measure of angle 1 plus the measure of angle 2 needs to equal 180. Measure of angle 1 plus measure of angle 2 has to equal 180 degrees. Well, fortunately for me, I've already got some information here. Don't trust it unless you see that box. That is saying that this is a right angle right here. So I know that the measure of angle 1 is actually 90 degrees. So 90 degrees plus the measure of angle 2 is going to need to equal 180 degrees. Well, I know if I want to get 180, 90 plus 90 would give me 180. So measure of angle 2 is going to have to be 90 degrees. Yes.
When you come out, be careful. The floor is big way.
Cool, thanks. Okay. So I now know that measure of angle 2 has to be 90 degrees. Let me put that in for myself. 90 degrees. Do we see any other supplementary angles that we can use? If I follow this line up, I see that I've got the line also going up here. I have a line going here. So there are multiple ways that I could use supplementary angles. I could say that angle 5, angle 6, and angle 7 are supplementary because they all form this 180 degree angle. So let's go ahead and say that. Angle 5 and angle 6 7 are supplementary, which would mean that angle 5, which we have is a right angle, 90 degrees, plus angle 6, which we do not know, plus angle 7 is 63 degrees, needs to equal 180 degrees. I already have 90 plus 60. I could combine that. I could say 153 degrees plus the measure of angle 6 is going to have to equal 180 degrees. Okay. That means that measure of angle 6 is going to have to be 27 degrees. So we can fill that in. That is 27 degrees now. That leaves me with angle 4, angle 3 that I still need to figure out. While we're on the subject of these types of angle relationships though, complementary angles. Complementary angles are angles where you end up with a right angle. So for example, if you had angle 1 and angle 2, you would say that the measure of angle 1 plus the measure of angle 2 are going to together equal 90 degrees. If you had a third angle in there, now you have 3 angles that all form that right angle, then you would add plus the measure of angle 3. All of that together needs to equal 90 degrees. In the case of our angles up here, we see that these two needed to form a right angle. So we can check and make sure that I did my calculations correctly last time by saying, does that match what I know about this complementary angle pair? I know that angle 6 and angle 7 need to form a right angle. So the measure of angle 6 plus the measure of angle 7 needs to equal 90 degrees. Right now I have 27 degrees plus 63 degrees. 27 plus 63, let's see, 83, 90. That does, in fact, equal 90 degrees. So I've got my complementary angles working for me over here. So then this leaves me thinking about vertical angles. So then I need to get myself over to angle 4 and eventually over to angle 3. When I'm looking for vertical angles, I'm looking for 2 lines or line segments that are crossing in some way. If they're crossing, the opposite angles are going to be mirror images of each other. That means that those opposite angles are going to be the same. So if this is 35 degrees over here, that means it's also going to measure 35 degrees on this side. Conveniently, when you've got vertical angles, you always end up with 2 sets. This angle is going to be vertical to the bottom angle. So then I would also know, well, if this is 35 degrees, we have a supplementary angle pair here. This needs to all be 180 degrees, which means that this needs to be 145 degrees. 145 degrees here, it's going to be 145 degrees on the bottom as well. So let's look for vertical angles up here. I'm wanting to get this angle measure. So let me fill that in and see if I can find vertical angles to that one. Looking at this, I know that this line is one side of that angle, and this line is the other leg of that angle. And if angle 4 is contained between those 2 lines that I just traced, on the other side, angle 7 is contained between those 2 lines. So angle 7 and angle 4 being opposite to each other in those cross lines are vertical angles. I would say that angle 7 and angle 4 are vertical, which means the measure of angle 7 is equal to the measure of angle 4. Since the measure of angle 7 is 63 degrees, that means that I know that the measure of angle 4 is also going to be 63 degrees. So now I know all of my angle measurements in this puzzle except the measurement of angle 3. That's where I'm going to use what I know about triangles. We talked about this yesterday, and we found that the measure of angles in any triangle is always going to be 180 degrees. So if you add up angle 1, angle 2, and angle, and it's not this way. In this triangle, our angles are called angle 2, angle 3, and angle 4. So we would say angle 2 plus angle 3 plus the measure of angle 4. That little n means measure. I'm measuring them. is going to be 180 degrees. So, do I now measure 2? Yes, I know that the measure of angle 2 is 90 degrees. Measure of angle 3, I don't know. And the measure of angle 4 is 63 degrees. All of that needs to be 180 degrees. At this point, it's algebraic. I can combine my 90 and my 60 to say I'm going to have 153 degrees plus the measure of angle 3 is equal to 180 degrees. And we already did this one. If we have 153 plus something equal to 180, we're going to end up with that unknown is going to be 27 degrees. So my measure of angle 3 is now 27 degrees. So to recap, with this angle puzzle that we've got up here, I was able to use supplementary angles, where things added up to make a straight line. I was able to use complementary angles, where I ended up with a right angle, or 90 degrees. I was able to use vertical angles, where things crossed, and I colored it in or color-coded it. It kind of looks like a butterfly or a bow tie. They're across from each other, and they're the same measure. And then I also used what I knew about triangles, and that the interior or inside angles of any triangle are going to add up to equal 180 degrees. So, I took all 4 of those things and put them into one problem. There are a lot of places where you can practice, and I'll put some in the comments, or not in the comments, in the description to this video, so you can practice with them in more isolated ways. But I wanted to show you how that all can fit together while also reminding you of what those different angle relationships end up looking like. Okay? I will talk to you tomorrow. Bye.